This video is aimed at students who have already learned the series expansion for basic functions such as e to the power of x, cosine x, and sine x, and want to learn some applications from knowing these series. So, one thing we see right away by looking at these three series is that part of the cosine series terms are present in the e to the power of x term, even though some of them are negative while the e to the power of x terms are all positive. And also the ones in the sine x series are present as the odd terms, even though some of them again are negative, whereas e to the power of x they are positive. So I wanted to experiment by plugging in I times x instead of x into the e to the power of x series. And by the way, I is defined as the square root of -1. So let's plug in e to the power of I times x. And that's going to be equal to the series from n equals 0 to infinity of ix to the power of n. Because we're replacing x with ix over n factorial. And that's just going to be, well, the first term is n equals 0, so I to the power of 0, x to the power of 0 over 0 factorial. By the way, 0 factorial is 1, not 0. And actually, I'm going to do that in yellow. You'll see why in a sec. X to the power of 0 over 0 factorial plus, let's do this other one in orange, I, because I to the power of 1, times x to the power of 1 over 1 factorial plus I squared. And by the way, I squared, if I is the square root of -1, then I squared is the square root of -1 all squared, or -1. So this is going to be -1 times x squared over 2 factorial, then plus I to the power of 3 is just I squared times I, or -1 times I, so -1 times I, x to the power of 3 over 3 factorial, and so on and so forth. Now there's something interesting. The yellow series, let's try to write out the yellow series. Now the yellow series starts at x to the power of 0. So it's the sum from n equals 0 to infinity. And it starts at x to the power of 0. And the first term is positive. The next yellow term is negative. The one after that is going to be positive. So it alternates. -1 to the power of n, right? Because when n is 0, this is positive, then it'll be negative, then positive. And it goes up by 2 each time. The exponent on x goes up by 2. So x to the power of 2n. And the factorial also starts at 0, 2, 4, 6. So 2n factorial. And that's the yellow series. Now let's try the orange series. The orange series always has an I in it. So the sum from n equals 0 to infinity of, and it always has an I in it, so let's write I. Now this one also alternates. So this term here is positive, this term here is negative, the term after that's going to be positive. So -1 to the power of n. Now the exponent on the x starts at 1, then it's 3, then it's 5. So it'll start at 1 and then go up by 2 each time. So 2n plus 1, because when n equals 0, this is going to be 1. When n equals 1, it's going to be 3. And same for the factorial. 1, 3, 5. So 2n plus 1 factorial. Now, do these look familiar? Look at the yellow series here. And look at cosine x. They're exactly the same. So we can rewrite that series as cosine x. Now look at the orange series. We can actually factor out this I. The I over here, we can actually take it out in front of the series. So it would be plus I times the sum n equals 0 to infinity. -1 to the power of n, x to the 2n plus 1 over, oops, all over 2n plus 1 factorial. Now this looks a little more familiar. This is actually the sine x series expansion. So, this is, use yellow again, cosine x plus I times sine x, because this whole chunk over here is sine x. So I times sine x. So we just discovered that e to the power of I x is equal to cosine x plus I times sine x. Now this formula is already interesting within itself, but it's even more interesting when you plug in pi where x is. So if we go e to the power of I times pi, that's going to be equal to cosine of pi plus I times sine of pi. Now what's cosine of pi? Well, that's just, let me draw out a unit circle. Although you guys should be pretty used to this by now. Cosine of pi is just -1, since pi is halfway around the circle, and cosine is your x value, which is -1. So -1 plus I times sine pi. Sine is just your y value, which is 0. So e to the power of, let's scroll down a little bit, e to the power of I pi is actually equal to -1. And that's an interesting proof you can do knowing some simple concepts in series expansions of functions.